Iron is a chemical element in metal, one of the most abundant elements on Earth. In fact, it makes up about 5% of the Earth's crust and can also be found on the inner and outer core. Iron is made up of atoms and in its pure form consists of atoms arranged in a crystalline structure. However, it can also be combined with other elements. Hematite and magnetite are the main minerals that are used as ore to make iron. Some physical properties of iron include solid, silver grayish color, and it rusts easily. Iron is atomic number 26 on the periodic table and the symbol Fe. Here's some pictures of what iron looks like. How does iron form? Iron ore formation commonly begins with the weathering of iron-rich rocks such as volcanic basalts or granite. As these rocks weather, they release iron ions into the water. These ions can be combined with oxygen and other elements to form iron oxide minerals, which then settle to the bottom of the water and accumulate as iron ore deposits through a process called precipitation. This forms iron oxide minerals such as hematite, magnetite, and goethite. So, what is the timescale? The replenishment of iron minerals / rocks varies from hundreds to billions of years. For example, igneous rocks containing iron can form quickly. On the other hand, the formation of iron-rich sedimentary rocks occurs over a longer timescale. Another factor that plays into this is human mining. This can back up the process because people use up iron at a faster rate than it can be replenished. Is iron renewable? Iron is a non-renewable resource because it can't be naturally reproduced and it takes a vast amount of time to form. In fact, most of the ore today developed billions of years ago.
The story of iron's origin is astronomical. It begins with the element being born from the explosion of stars, also known as a supernova. The iron ore deposits are found in sedimentary rocks formed by the chemical reaction of iron and oxygen mixed in marine and fresh water. The important iron oxides in these deposits are hematite and magnetite. These are ores from which iron is extracted. The iron ore deposits began forming when the first organisms capable of photosynthesis began releasing oxygen into the waters. This oxygen immediately combined with the abundant dissolved iron to produce hematite or magnetite. These minerals deposited on the seafloor in great abundance, forming what are now known as the banded iron formations. The rocks are banded because the iron minerals deposited in alternating bands with silica and sometimes shale. The banding is a result from seasonal changes in organism activity.
The importance of iron dates back to the formation of the Earth, where the amount of iron in the Earth was the perfect amount to be able to sustain life. According to the Associate Professor of Planetary Materials at the Department of Earth Sciences at the University of Oxford, too little iron in the rocky portion of the planet, like the planet Mercury, in life is unlikely. Too much, like Mars, in water may be difficult to keep on the surface for times relevant to the evolution of complex life. Also, iron-bearing rocks provide valuable insights into Earth's history and geological processes. These rocks, formed through complex geological events, tell a compelling story of the planet's evolution over millions of years. The presence of iron in different geological formations can indicate specific environmental conditions during their formation. For instance, banded iron formations, characterized by alternating layers of iron-rich and silica-rich bands, often point towards ancient oceans and atmospheric changes. By studying the composition, structure, and distribution of iron-bearing rocks, geologists can find clues about past climates, tectonic activities, and the interaction of various elements that have shaped our planet. This deeper understanding not only enhances our knowledge of Earth's history, but also contributes to predicting and comprehending future geological processes and environmental changes. Not only was iron extremely important for the ability to sustain life and growth, today iron is the backbone of our world and is the basic ingredient in steel. Steel is a fundamental material in construction and manufacturing, but the importance of iron goes beyond industry, as it has been a pivotal factor in human progress, influencing technological advancements and economic development. It is the most abundant rock-forming element, making up about 5% of the Earth. It is so important that every American will need around 24,416 pounds of iron in their lifetime. Iron is a crucial mineral with immense importance in our world. Its largely versatile nature makes it useful for so many different things. About 98% of the world's iron is used to make steel. Iron has many specific uses like pipes, fittings, and engine blocks, but pure iron is quite soft. When adding a small amount of carbon, iron turns into steel, which is significantly harder and can be used for so many things. Electric motors are made of iron, powering our homes, appliances, and industry. On average, 75% of the weight of a typical household appliance comes from steel. Iron's magnetic properties make it crucial for various applications, from magnets in everyday devices to more advanced technology like MRI machines and medical diagnostics and magnetic storage and data systems. The iron and steel industry is a major contributor to the global economy, providing employment opportunities and fostering economic growth in numerous countries. It is a cornerstone of industrialization and infrastructure development.
Where can we find iron? Iron can be found in many countries, including Australia, Brazil, and Russia. Australia has the most iron of any country with over 48 billion tons of the material. Brazil has the second most with 29 billion tons, and Russia has the third most with 25 billion tons of iron ore. A fun fact about Brazil is that it is also home to the largest iron mine in the world, the Carajas mine, holding over 7.2 billion tons of iron. Over 50 countries around the world produce iron. These countries span 6 continents. The U.S. is the 13th largest exporter of iron and is therefore not dependent on other countries for the resource. We produce our own iron, making it easy to access. Earth's most important iron ore deposits are found in sedimentary rocks. They form from chemical reactions that combine iron and oxygen in marine and fresh water.
Why is iron located here? The country of Australia itself produces a higher amount of hematite iron ore than any other country, which contains a larger quantity of usable iron than itabarite or magnetite. Therefore, iron in Australia will be in greater quantity than anywhere else on Earth. Stratigraphically thick, massive IFs, commonly referred to as superior iron formations, have been classically tied to the presence of low oxygen water masses, allowing high concentrations of dissolved ferrous iron Fe2+ to accumulate. During the 1980s, A.F. Trendle, working for the Geological Survey of Western Australia, studied deposits in the Hamersley Basin and found that individual thin layers could be traced for more than 100 kilometers. Such continuity suggests that evaporation played a major role in precipitating both the iron minerals and the silica in the area.
Since iron is used to make steel, which is a fundamental resource in society, we would still need it in our economic future. Steel is used in construction, making automobiles, shipping, and creating consumer goods, and more. The steel industry generates about 7% of all man-made emissions and is the largest emitting manufacturing sector. Steel demand is projected to rise 30% by 2050. Furthermore, it is highly unlikely that the world will run out of iron anytime soon. This is due to the vast reserves available, as well as the constant advances in mining technology and ongoing recycling efforts to guarantee a steady supply of iron for years to come. In regards to the worldwide trade, American and Chinese tariffs were introduced in 2018, but it did not reduce trade. Trade products affected by tariffs grew amongst the rest of the world, but it was merely reallocated but not reduced. This means that iron trade was not reduced across the world, and fair trade as well as access to iron is still present.